So one thing that you need to understand, now I'm gonna speak about the reaction that we normally say it's what it's hydrohalogenation. Hydrohalogenation. If you can be able to locate ukuthi ama-alkenes, they undergo 4 reactions, and then you know how to get those type of reactions or to see the difference, then it's not going to be difficult when working with organic chemistry, because the whole of organic chemistry comprises of that. So when you speak about hydrohalogenation, that is addition of hydrogen halides. So this one is an addition of hydrogen halide. You just write here that this is addition of hydrogen halide. Hydrogen halide to alkenes. If they ask you, Uguti, what is hydrohalogenation? That is an addition of hydrogen halide to alkenes. So when we're saying it's an addition, it means to say we're gonna add. What are we gonna get? What are we gonna add? We're gonna add the hydrogen halide. So when you speak about hydrogen halide, it's a what? It's you adding a halogen that comprises of hydrogen at the same time. That's why we are saying hydrohalogenation, because it comprises of hydrogen compound or molecules together with halogen, of which I've explained to say halogens, those are organic compounds which you find them on group 7 or group 17 on the periodic table. So here, continuing, we know that the addition of what? Of anhydrous and hydrous. Let me do like this. Yeah. Anhydrous hydrogen halide. It's much better. Hydrogen halide. So when you speak about hydrogen halide, it will be shown with an HX in most instances. It will be shown with an HX in most instances. Why do we show it with HX? H comprises of hydrogen, and then X in most instances, it basically represents the halogen that I'm just explaining. So in most instances, X, it represents a halogen, of which you know that when we speak about halogen, we're speaking about bromine, iodine, fluorine. Those are atoms which are diatomic molecules in nature. So, such as, let me change this, such as what? Such as you having HCl, which is called hydrogen chloride or hydrochloric acid. HCl, we know that is hydrogen chloride or hydrochloric acid, comma, you having HBr, hydrogen bromide, and HI, hydrogen iodide, to alkenes. I'm just giving you some basic that you must know, and then we will come to the reaction part. Alkenes leads to the following. Reactions. So the first thing that one should know is the following. Let me use this one. So the addition of hydrogen bro bromide to ethene product. So each and every time you add addition, each and every time you add hydrogen bromide to ethene products, it produces what? Comma, it produces, we're all gonna be knowing that it will produce the following, which is what? Bromoethane. Bromoethane. Then if you can be able to understand the statement that I've just wrote here, this one, then you are not going to struggle with regards to you understanding the reaction that is going to take part thereof. So when I'm saying the addition of hydrogen bromide, you understand that you are adding hydrogen bromide. So I've just explained to say this hydrogen bromide, we call it what? A hydrogen halide. You know why? When we are saying it's a hydrogen halide, it means to say it's a hydrogen that comprises of a halogen, and then you are not restricted. All the halogens, these are the ones which are on group 7 or group 17 on the periodic table. So that's why I'm saying the addition of hydrogen halide. This hydrogen bromide, we call it hydrogen halide. Even if someone didn't say hydrogen bromide, someone can write hydrogen iodide. It simply means to say that particular person will have used a hydrogen halide, in that case being iodine. So the addition of hydrogen bromide to ethene products. So if you can understand the statement, you're not going to go wrong in this instance. When we are seeing the addition of hydrogen bromide, it means to say somewhere, somehow, you must add what? With regards to your addition reaction, you're going to add what? You're going to add, let me use a different color. You're going to add hydrogen bromide, which we normally say it's HBr. So if you understand this statement, then it makes your work to be much easier, because when we are saying the addition of hydrogen bromide, you can see addition, it's plus. Hydrogen bromide, you add what? HBr. To ethene, it means to say, when I'm saying to ethene, you understand that it's an alkene that has 2 carbon atoms. And don't forget that alkenes, they have a double bond in the middle. You get to see that. Then you're going to have something like this. Here it's hydrogen, here it's hydrogen, here it's hydrogen, here it's hydrogen. Where am I taking this from? From this statement where I've just made a star. When I'm saying the addition of hydrogen bromide, you add plus HBr. So here, someone will add hydrogen bromide. Here, someone will add hydrogen fluoride, which is HF. Someone will add a hydrogen iodide. Why? Because all those are halogens on group 17. So the addition of hydrogen bromide to ethene, you understand that this is a structural formula of what? Of ethene product. It produces what? Bromoethane. So when we are saying it produces, it means to say it will undergo a chemical reaction whereby it produces bromoethane. So just because of now you understand that this is bromoethane. Ethane is an alkane. Somewhere here, the end byproduct, it must be an ethane. You know why? Because we understand that, oh, this will produce a bromoethane. So for the method that it's a bromoethane, it means to say it's an alkane that has a halogen, right? So when I'm saying bromoethane, it's an ethane that has bromine, so to say. So here we understand that this is H, that is hydrogen right there. Then that's another hydrogen, that's another hydrogen. So now you count the number of hydrogens for you not to be on the wrong side. So that's 1, 2, 3, 4. So those 4 are these ones. 1, 2, 3, 4, right? And then after counting those, we're also having hydrogen, which is this one. And then now you are also having what? Bromine. So it means to say here, you must have PR. You know why we are having PR? It's because of here, you must produce bromoethane. So ethane is an alkane. This is a structural formula of a what? Of a haloalkane. The reason I'm saying it's a haloalkane because it's an alkane that comprises of a halogen being bromine. So its name, it's a haloalkane, but its name is what? It's bromoethane. So that's what I'm saying. If you can understand this statement, then you are not going to go wrong with regards to that. Why? Because if you go back to what I've just showed you, I said what? Hydrohalogenation is an addition of a hydrogen halide. So we have added here hydrogen halide. You get to see that. But let's now continue. So this basically means to say here you understand that after having this structural formula, the name, what is going to be, we are going to have ethene. Ethene, because of a double bond, it's an alkene. Get an alkene that has 2 carbon atoms, we call it eth. Plus, here we are having what? Hydrogen bromide, which is a hydrogen halide. You write hydrogen bromide, and then we produces what? A haloalkane. We produces haloalkane, which is called bromoethane. So this bromoethane, what do we call it? This bromoethane, we are calling it a haloalkane. And then this hydrogen halide, this hydrogen bromide, we call it the hydrogen halide. Just like that. So these things, they're not difficult. They just want you to know the basics, because the entire part of organic chemistry, if you don't know the basics that I'm teaching, then you might be in trouble, because almost from question 1 to question 4, if I check question papers, it's only organic chemistry, but structured in different manners. So you need to know how to draw a structural formula, condensed structural formula, the IUPAC naming, you drawing the structural formula as well as the naming part. So now we are still on the part of organic reactions. After I'm done teaching you the organic reactions, we're gonna dive into answering those questions. You'll see basically how we're gonna answer questions. But I didn't want to do questions first, because you might be lacking on the basics part, which is this one. The next step that I'm gonna do when we will be dealing with questions, it will require us to know all these organic reactions that I'm teaching you. So the next time when I'm gonna say an alkene, it reacts with a hydrogen halide to produce a haloalkane, you must not get confused when I'm speaking about it, because I will be talking from experience of me coming back from teaching you this. Any question?
No questions.
No question. Okay. It's not only the case I'm gonna choose Ife. I can also choose an alkene that has 3 carbon atoms. So let's use that scenario so that you can get to understand to say, no, we are not only working with ET. So scenario number 2, as long as it's an alkene, and get scenario number 2, someone will say, myself, I'm not going to use ET, but I prefer to use propene. So in that case, you're going to have something like this. Propene, you know that it must have 3 carbon atoms. But the very important part is that this is an alkene, hence it comprises of a double bond. Then you're going to write hydrogen, not forgetting that each and every carbon, at least it must have bonds in it. It must have 4 bonds in it, so to say. And then that will be a single bond. And then here we're going to have a hydrogen. So this hydrogen, you can rather write it there, or someone will just prefer to write it underneath. You're not going to be wrong if you write it here. Either one of those is still correct. So let's just write it here on top, hydrogen. Then we're also having single bond, just like that. So here you'll put hydrogen, just like that. So that is our structural formula for what? For propene. As long as it's an alkene, must comprise of a double bond, propene. So that's why I'm saying you are not restricted. If you look at the previous one, it was eth. As long as it's an alkene with a double bond. So the only difference is that this one that we are coming from is an alkene that has 2 carbon atoms. And then the one that I'm currently doing, it's an alkene with 3 carbon atoms, just like that. And then still, you're going to add a hydrogen halide. Hydrogen halide, you can still choose hydrogen bromide. Hydrogen halide, when I'm saying hydrogen halide, you must not be confused. It's a hydrogen that comprises of a halogen, of which in this case, the halogen that I choose, it's bromine. But the end product, or the end product, you must always have a what? You must always have a haloalkane. And then this haloalkane, the only difference from the previous one is that the previous one, it was a haloalkane of 2 carbon atoms, because we're coming from eth, understanding that ethene, it has 2 carbon atoms. Hence, the byproduct, it will be a what? It will be an alkene with 2 carbon atoms. And then if you're going to use propene, which is an alkene with 3 carbon atoms, also the byproduct or the end product after the chemical reaction has taken place, you understand that you're going to have a haloalkane. But in this case, this haloalkane, it must have or comprises of 3 carbon atoms. Then you want to draw those 3 carbon atoms, taking into consideration that it's still going to be a haloalkane. Why? Because it comprises of a halogen in that regard. So here, you know that you're going to write hydrogen, and then here, you understand that this will be what? This will be a bromine. So the only difference, let me show you, that guys who will say, myself, I don't like using bromine, but I will rather use fluorine, or every element in group 7 or group 17. It means to say, if you have used fluorine here, as in like F, here you must have a fluorine, right? So it means to say it will still be a haloalkane. And then in that regard, you see this one, if you have used fluorine, the end product, it was bromoethane. If you have used fluorine, it will be what? It will be fluoropropane, because propane, it comprises of 3 carbon atoms. So you need to be very careful of that. So that's only the difference. Any question? So let me erase this one. Any question? So this one, remember, yeah.
If they didn't specify which carbon you are going to bond bromine with, you can bond, you are going to bond HBr with. Like if they didn't tell you if they want a major product or a minor product, you can bond it with any hydrogen.
No, that's why normally we have, yeah, let me answer you. It's a good question. So where you put your bromine is closer to the double bond. You see this one? Let me show you something. Ne? But when I hear the double bond was here, situated on the, because when we name, remember, we always look number, we choose the longest carbon chain, number 1. Those are the rules of naming. Number 2, we always name closest to the double bond. So I'm getting this is 1, 2, 3. I will prefer to name that is the correct naming part, because if you're gonna name it the other way around, let me show you something. If you're gonna say 1, 2, 3, it means to say your double bond is on the second carbon, of which is wrong, because the rules of naming part, it says that we choose the longest carbon chain, yes, and then we name closest to the double bond. So when you look at this one, this number, the double bond is on the second carbon atom. But if I were to number it like this, 1, 2, 3, you can actually see that the double bond is on the second carbon atom. That's why I'm saying, if you're gonna name, you don't choose to put a bromine here or there. You'll be wrong if you're gonna do like that. You put bromine closest to that double bond where it was, and get the double bond, it was somewhere here, and then it broken down. That's why I'm adding bromine. And then for you not to get confused, because it's a good question in this sense, that's why we are having 2 definitions, which I actually taught. I said we're going to have what you call Markovnikov's rule, if you still remember. I'm just going to tell you now. Let me write it first. Markovnikov's rule. I'm not sure with my spelling, but it's Markovnikov's rule. And then the other one is Zaitsev's rule. So we are having these 2 rules in chemistry, which are very important. So this one, I forgot what it means. But Markovnikov's rule states that when an asymmetrical reagent is added to an asymmetrical alkene, the carbon atom will be attached to, the number of carbon atoms will be attached to the carbon atom with the greater number of attached hydrogen atoms. It's something like that. It's a definition called the Markovnikov's rule. So it means to say, when you are working with this type of organic reactions, the part where you are going to put this bromine, you will be guided or being guided by Markovnikov's rule, because that's why normally when you look at this, the double bond, it was here on the first carbon atoms. That's why even my bromine, I'm put it on the first carbon atom, because I'm following Markovnikov's rule. I will be wrong if I will put the bromine here, because look at the double bond, it's there. Then I will be wrong in that case. So it's very important that you know Markovnikov's rule. It's just a mere definition that one needs to know, because also I've explained it in the previous video. I think video number 1, I've explained Markovnikov's rule properly, how it works. And then if you can also enter the exam, and then they will say define Markovnikov's rule, because the way they said these questions, and then before they can, coming back to your answer, before you can ask that question, they will say, okay, define Markovnikov's rule. After that, then now they want you to apply the scenario that you just gave me as an example, or the one that I'm just explaining in response to your answer. So you must know those, of which is very important. Did I answer you?
Yes, sir.
Yes. So this one is hydrogen halide. Hydrogen halide. And then if they can say, name it, you'll know that, oh, that is hydrogen bromide. If they can say name it, you'll just write hydrogen bromide. Bromine, it becomes bromide, just like that. Any question? Not only that, again, another thing, let me show you. For the mere fact that the double bond, it's in between carbon number 1 and carbon number 2. It means to say your end product, if you're not going to put the bromine here, you'll still be correct only if you put the bromine here. You know why? Because that bromine that you are putting is still follow Markovnikov's rule and is still between carbon number 1 and carbon number 2. Even if that broke, that double bond, it will broke up until it gives us an alkane. So you are not going to be wrong. Another only correct answer is you drawing a structural formula whereby you rearrange. Here in the middle, you put bromine, and then here you put hydrogen. You're still going to be correct. You know why? Because you're following the concept to say, as long as the bromine is between carbon number 1, carbon number 2, from the naming part of that alkene that you are seeing on the onset, we have just drawn the structural formula, then you still be correct. Am I making sense?
Yes, sir.
Yes. Or I think it's best if I draw it. So remember, you're still going to have here is another option that I'm just explaining just now of changing the location of bromine. So another person can write this structural formula. You're still going to be correct if you write bromine here. And then the rest, it's a matter of you putting a hydrogen, 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 hydrogen. So it means to say these are the only two byproducts of how you can put the location of bromine, either the first one or the second one. Is still going to be correct because you are being guided by this double bond. And then in an instance whereby the double bond it was put maybe somewhere here, it means to say you now know the location of where you put the bromine. And then now let's put this. Let's put this because it's very important. So the reactants, you can actually see that on the reactants part, we are having what? We're having an alkene because it's a double bond. Adding it with the what? With the hydrogen halide. Hydrogen halide. You just write hydrogen halide. Then the products formed. Okay, before the products, type of reaction. The way I'm gonna teach chemistry is very easy. You'll understand why I'm saying this. Let me show you. So when I'm saying type of reaction, who can tell me what will be the type of reaction? And it we added the hydrogen halide here. Let me show you. And it here we added the hydrogen halide. Are you with me, guys?
Yes, sir.
So since we added the hydrogen halide, hence it becomes an addition reaction. There's no way we will say alkenes they undergo substitution reaction. The only type of organic compounds that undergo substitution reaction for now that I've just taught, it's alkanes. Alkanes they undergo substitution reaction, and alkanes they don't undergo addition reaction. And then now since we're in alkenes they don't undergo substitution reaction. They undergo addition reaction because we are adding. So when you must be very careful with regards to the English there. When they're saying type of reaction, that's when you will write and say addition reaction. Write addition reaction. And then when they're saying, you look at the English, when they're saying type of addition reaction, type of
It's hydrohalogenation.
that's why you say what?
Hydrohalogenation.
Yeah, not halogenation. That's why I ask you twice. It will be what? Hydrohalogenation. So type
Yes,
of
sir, I said hydrohalogenation.
okay, yeah. But I'm glad that now you understand. So type of addition reaction, because you added the hydrogen halide, then it will become hydrohalogenation. So do you see how we answer these questions? Here you will say
Yes, sir.
yes, hydrohalogenation. You know the way I'm teaching, trust me. They will ask you, they will draw a structural formula. Organic chemistry is good in a point whereby if you can know the basics from the structural formula part of knowing, okay, Guti, ama alkenes they undergo addition reaction. And you now know Guti, when you are saying addition reaction, what do you add in the first place? They will ask you questions which regard to, they will say type of reaction, then you understand, oh, if it's an alkene, that's going to be addition reaction. But if they're saying type of addition reaction, then it means to say you must answer them and say hydrohalogenation. And then the product formed, it will be what? The product formed, it will be a haloalkane because it's an alkane that comprises of halogen. So here the products formed, you'll say it's a haloalkane. Haloalkane. Am I making sense?
Yes, sir.
So from me teaching you this, you understand that, okay, we can now conclude and say, therefore, alkenes, they undergo what? They undergo addition reaction. They undergo addition reaction. Addition reaction to form what? To form ama haloalkanes. Very, very, very easy. As easy as that. So now it means to say, even if we were to end this session, I'm 100% confident to say I know that from just mere teaching you this, you are not gonna forget, because now you understand Uguti. Even if we will end up the session just now, I'm just saying in passing, I'm now confident to say you'll know to say, oh, you'll never get confused to say, oh, alkenes, they undergo addition reaction. Why are they undergoing addition reaction? Because we are adding a what? We are adding what? A hydrogen halides.
Hydrogen halide.
Yes, to form haloalkene. So for the method that we are adding hydrogen halide, it comprises of a halogen. Then it must be an alkene that comprises of halogen, which we call it a haloalkane, just like that. Am I making sense?
Yes, sir.
Any question?
No questions.
Yeah. And then that is the third reaction. I told you that on the previous video, I said alkenes, they undergo addition reaction to form a what? If you still remember, to form alkenes, they undergo hydrogenation. The type of reactions that you'll find for alkenes is hydrogenation. The first one, whereby you are adding a hydrogen. And then the second one is halogenation, whereby you're adding a halogen. And then the third one is this one. Since you're adding hydrogen halide, is hydrohalogenation. And then the last reaction under alkenes is what? Is alkenes undergoing what? Hydration. Hydration to form alcohol. So hydration, it's addition of water to alkenes. So the fourth one. So the first reaction and the second one, I did it on the previous video that is uploaded there on the YouTube. And then this one is the second one. That's why I'm saying organic reaction number 3. Then lastly, organic reaction number 4, of which this one we call it hydration. Hydration. So hydration is what? It's addition of water to alkenes. Addition of water. You understand that the formula for water is H2O. 2 hydrogen molecule as one is 1 oxygen molecule. So hydration is addition of water to what? To alkenes. I wonder if you know this, you're not gonna struggle, because when I'm saying addition of water to alkenes, you can choose any alkene that you can ever choose. So the first alkene, you know that is what? That is an ethy. But in this case, let's check propene. When I'm saying addition of water, it means to say, it's very easy. You understand that you're gonna add water, H2O. And then to alkenes, it means to say, when I'm saying to alkenes, you can choose any alkene that you ever think of. So let's choose an alkene that has 3 carbon atoms. This is very easy from how I teach it. Hydrogen. Also having hydrogen. And then when we're adding water, you understand that, look at this. we understand that the byproduct, it will be what? It will be an alcohol. It will be an alcohol. So we're going to have 3 carbon atoms, which is going to be 1, 2, 3. It's going to be an alcohol. You know why? You know that an alcohol, the name ending, it's all, hyphen all. It means to say we're talking about an alcohol because here we're going to have this O. Hence, we are saying it's an alcohol. Now let's continue. So it's going to be like this, right? And then here, hydrogen, 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 right? And then another hydrogen there, another hydrogen, and then here we're gonna have what? We're gonna have an OH here. You know why? Let me show you. If you count the number of hydrogen atoms, it's 1, 2, 3, 4, 5, 6. So since there's 6 on the left hand side, let's check this one. It's 1, 2, 3, 4, 5, 6. Do you see that now you are left with H2, H2, which is this one, together with O, which is that one. So it means to say your equation is kind of like balanced. And then now everything is now 100% correct. And then now, since we're working with this, you understand that here, what are we having? We're having propene, because propene is an alkene with 3 carbon atom, propene. So don't forget, when I'm saying addition of water to alkenes, you can choose any alkene. In this case, I've just chose propene, which is an alkene with 3 carbon atoms. So you are not limited to that. And then you are adding what? Water. H2O, we know that we are adding water. And then it means to say we're going to have an alcohol, which we call it what? 2-propanol. 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 Or someone who doesn't say 2-propanol will say what? Propan 2-ol. Propan hyphen 2-ol. It's one and the same thing. So that's how it is. So it means to say, now one can conclude boldly to say, okay, alkenes. Let me show you something. I show here previously the previous organic reactions. I said alkenes undergo addition reaction to form a haloalkane. And then with regards to this one, it will be alkenes, they undergo what? Addition reaction to form an alcohol. Addition reaction to form what? To form an alcohols. And then when I'm saying alcohols, it's not always the case that the alcohol byproduct, it will be 2-propanol. No. This one, why are we saying 2-propanol? It's because of, I'm coming from a perspective of me saying I've just chose propene. So that's why we are saying 2-propanol. If you're going to use an alkene that is maybe butene, it will be what? It will be, it might be 2-butanol or butanol. Do you get to see? I think now you have a clear understanding of how it works. So with regards to the alkene, you are not actually limited with regards to that. And then here we understand that our reactants is going to be what? Our reactants is going to be what? An alkene reacting with water, which is H2O. Water, which is H2O. And then the type of reaction, here comes the important part. Type of reaction. Who can tell me what is the type of reaction?
It's addition.
100% addition. We're going to write addition reaction. Addition reaction. Say, do you understand?
Yes, sir.
Okay, cool. And then since it's addition reaction, when I'm going to say type of addition reaction, who can tell me? It will be what? Since we have
Hydration.
Yes, since we have added water, it will be hydration. 100%. It will be hydration. Hydration. And then the products, it will be what? What will be our products? It will be an alcohol. Anish?
Yes.
Yes, alcohol, just like that. So now from this session, you can be able to say, now I know to say, since now we are having 4 types of reaction. The first one is what? It's hydrogenation, where we are adding hydrogen. The second one is halogenation from the previous video. And then on this video, which is the third reaction, we understand that alkenes, they undergo addition reaction to form what? To form haloalkanes, as well as alkenes undergo what? Addition reaction to form alcohols. So it means to say you must be in a situation whereby you understand to say you know all those type of reactions that alkenes they undergo. So it means to say from this session, I've already covered all the reactions that you can ever think of that undergo alkenes. Alkanes, I'm done. Reactions. And then these ones are the alkenes based on the previous ones. Again, when you combine them, these are only reactions that happens on alkenes. And then on the next session today in the evening or during the day, we're going to go to organic reactions that are taking place under alkynes. And then after that, we'll go to esterifications. Esterification, carboxylic acids, will go to those. But for you to understand esterifications, carboxylic acids, you need to know this basic first. And then we'll go to those more advanced ones. Then we deal with whatever question that you may ever come across. Any question?